Guys, I'm making this video because I need to talk to you about standard prep. Now, I know that you've just watched a couple of videos and you're probably saying, well, I know all there is to making some standards. And I'm not saying that you don't know how to make standards. But what I am saying is that there's something particular about standards in the GC world that we need to discuss and talk about. All right? So we have kept saying that there is a no-no in the GC world, and that no-no is water. Now, I want you to go back and I want you to think of making a set of standards in every class pretty much that we have had up to this point. And what's happened is that you have added your solution down in the inside of a volumetric flask. And then what's happened is that most of the time, I think every single time up to this point, you have added water up to the line in the volumetric flask, right? Okay, well, the problem with the GC is that you can't add water. We've already discussed this. Now, there's ways around it, but in a normal, typical GC world, water-based standards and samples are not going to cut it for us. So there's got to be another way. There's got to be another way that I can make a set of these standards and run them. Because just like what we've discussed or what we have been discussing is that you should be able to get a linear calibration curve on a GC instrument, right? You make a series of standards, just like always. You run those standards on a piece of equipment. They should be a linear relationship, and you should get a linear curve. And we should get a y equals mx plus b. The problem, now that you're finding out, is the water. You got to get rid of it or not use it at all. All right, so there's a very easy way around this. Let's say that I was making a standard of benzene. Okay, so one of the labs that you might be doing in the program is analyzing a solution of benzene or a solution of gasoline and measuring the content of benzene on the inside. There's a couple of ways to do this. One of the ways is to make a set of standards. So what will happen is that I will go to the lab and I will get some benzene, and benzene's going to be in a bottle, and that benzene is a liquid. So I need to make a set of standards using benzene. And I probably need to be making them in part per million or part per billion or molarity, whatever the case is. It's kind of the same thing that I've always done, right? I'm going to take a certain amount of this stuff, and what will happen is that I will choose a volumetric flask. I will add a known amount to that volumetric flask, and up until now, you've always added water, I think, to make these standards with. Well, you do the same in the GC world. Okay, yeah, benzene's a liquid. There's a little bit of extra calculation that goes along with it. Most of the samples that we're running in GC are going to be liquids. No big deal. And I'm going to add that to the volumetric flask, but I need to choose the proper solvent. Okay, and there's two solvents that we will traditionally use in the GC. And number one is going to be acetone. And number two is going to be methanol. These are the two solvents that are traditionally used in almost all of the GC methods. If you take a look at the standards, especially if you've watched the video already of this small kind of amber looking vial that has an etching on it, and then it kind of points up to a tip, and the guy snapped and broke it and then transferred that standard into another container where he then used it. All of those types of standards are going to be dissolved in acetone or methanol. And the reason is because both of these are pretty low formula weight compounds. They also have fairly low boiling points, and these do very well of trapping and keeping organics, which is really what we're after and what we're doing in the GC field, right? So I would take some benzene, I will add some benzene to a flask, and instead of adding DI water to it, I would just add acetone up to the line, and then I would invert and mix, and now I've prepared my sample. Okay? Or if I didn't want to add acetone, I could add methanol instead, and it would do the same exact thing for me that acetone would do as well. Why is there a choice? Well, some things dissolve in one better than the other one, but these are the two most common that you will always see. In addition to that, these things, well, acetone, methanol, they're fairly cheap, so the cost is down as well. So let's think about it. If I don't know why it keeps doing that. If I had to make a set of standards, and let's say that I'm required to make 7. All right, so here's 4, there's 5, there's 6, and there's 7. And let's say they're 100 milliliters each. Well, I've added maybe benzene to each one of these all the way through. A little bit more, little bit more, little bit more, on up 1 through 7. Well, I'm probably adding very small amounts of that standard, maybe the benzene. Again, if that's the example that I'm using. And these things could actually be like fractions of a milliliter. We're talking like 0.2 mils, 0.3 mils, 0.5 mils, 1 milliliter if you're lucky. I mean, these things are super, super small. And then to make these standards, I'm then going to add acetone or methanol until I get up to the line. So there's a chance, depending on how many samples that I will be running, that I could be using 500 to 700 milliliters of acetone or methanol in order to make my standard set. I'm going to be drinking these solvents because I'm using so much of them. So that's why we need something pretty cheap, right? And the reason is because the GC does very well at low concentrations, and I need to be making very low concentrations. Okay, so what does that actually mean? Well, let's give you an example. I mean, we're talking about benzene here, so let's keep benzene. And benzene has the structure of a ring with an alternating single, double all the way around. So let me draw that. Again, it seems like I'm looking crooked today. All right, so there's our structure. And let's say that we put 1 milliliter of benzene in a 100 ml volumetric flask. And we want to calculate the concentration of that solution in part per million, okay? Now, keep in mind, part per million means milligram per liter. All right, well, I kind of already have the setup almost here. I know what the liter is. All right, so I'm going to circle the liter down here at the bottom, and I know how much I'm making. I'm making 100 mils. So this is actually going to be 0.100 liter. And that's what that equation is going to require if I'm trying to calculate that concentration. All right, well, what about the 1 milliliter here? Okay, so if I've got 1 milliliter of benzene, it looks like I need to know the milligram of benzene. So I can do this, 1 milliliter, milliliter on top, milliliter on the bottom, and then I can go to gram of benzene. And this requires gram per mil, which is also called density. So if I know the density of benzene, I will be able to calculate the number of grams of that compound. And I'm just going to go ahead and chain it. Gram on top, gram on bottom. We need to go to milligram. And I know how many milligrams are in a gram, right? This is all dimensional analysis and conversion right here. So there's a couple of numbers that I've got to pick out. Number 1, how many milligrams are in a gram? Well, there's 1,000 milligrams in 1 gram. Milli is millennia, which means 1,000. Okay, well, how many grams are in a milliliter of benzene? Well, that requires a little bit of density knowledge, and I need to go to a textbook or go to Wikipedia, and I need to find the density of benzene. And that density is 0.876 grams per 1 mil. All right, so it looks like what I need to do is I take 1 milliliter of benzene, super tiny amount, and I need to multiply by 0.876, and I would get 0.876. And then I would take 0.876 and I would multiply by 1,000. So I would move the decimal 3 times. In the calculator, if you need it, put it in. You'll see that it will move the calculator 3 times, or move the decimal 3 places. So 876 milligrams is what I've got. All right, so 876 milligrams of benzene is what I have added into that flask, and I have put that into the presence of 0.1 liter, or 100 mils. Okay, so I'm going to bring up the calculator just so I can prove the point, so that way you know I'm not lying to you. So I'm going to take 876, and I'm going to divide this by 0.1, and what I will end up with is 8,760. All right, 8,760 part per million. Folks, this is way too strong. There is no way that you are going to be able to analyze something like that on a GC system. So the small amount of 1 milliliter in a 100 ml volumetric flask, I have used 99 milliliters of acetone or methanol to dilute it with. That's for that one standard, and I'm probably required to make a set of 5 to 7 standards in total. I'm going to, again, eat through those solvents, but that's just the way this nature is playing out in the GC world. And in addition to that, I have made super strong solutions that need to be ran. So this 1 mil, not going to cut it. When we make standards on the GC, we are probably going to be making them with microliters of solution. We're not going to be making them with milliliters of solution. If I can get into the microliter territory, then I can add very small amounts of these substances to my standards. I'm still going to waste through acetone and methanol, but this is going to lower the concentration here to a much more workable number. Now, what if we don't have microliter technology? Well, the answer to that would be you would have to make this one first. And from this one, you would then dilute down the rest of them that you would need to end up making. So take 1 milliliter of that substance and dilute it down again. Take a half mil of that substance, dilute it down again. Whatever you need in order to do your job, and get it to the part per million level that you that's acceptable on the GC, then that's what you've got to do. So a couple of weird things here. Okay, I'm just going to circle these. Number 1 is going to be the solvent amount. They're typically fairly large, and it's typically not DI water. So we have to be kind of conservative. We have to make sure that we're prepping these the right way before we do them. Number 2, take a look at your standard amounts. These standard amounts are pretty important because those are going to be extremely small. So my standard or my component is going to be pretty tiny, and we're thinking microliters most of the time here. Now, I apologize. I know that my U looks a little bit like the M sometimes, but that's just me getting careless. All right? So that's the proper way to make standards in the GC. Again, don't be surprised if you get vials or containers of prepped already, ready to go standards that you just snap, like the gentleman did in the video, and then you transfer that over to a container, and you can use that to make your standards with. The microliter volumes here, those are typically done with a Hamilton syringe, or they can also be done with a micro pipetter. So that's up to you on what you want to use. Hamilton syringes are typically the go-to, though, in this field, but micropipetters, if you feel comfortable with those and they're calibrated, you're more than welcome to use them. All right, so that's my word of advice to you about standard prep. Pretty important, kind of different than what you've done before up to this point, but this is the way it is. So get ready to eat through and drink through 4 liters of acetone of methanol because you're going to need it. And you can imagine our perspective. If you've got 10, 20 people in the lab that's all doing it, we're going to go through 10 liters of stuff before your sample standard sets are going to be made. We'll take donations, by the way.